Today I will start with signal and systems. Just remember one thing, you have to practice a lot, and I will cover almost all the concepts. Please listen and see carefully. All the best. Topic 2. Signals you should know. First signal is unit step signal. U of t is equal to 1 when t greater than or equal to 0. It is 0 when t is less than 0. For this time, just remember this statement. Now we will draw the signal. So by following this statement, for t greater than or equal to 0 it is 1 and t less than 0 it is 0. We will draw it like this. If somebody asks you what is the value of unit step signal at t equal to 0, so you will say it is 1 by 2. This we do because we need the value of unit step signal at t equal to 0 sometimes while doing mathematics. So that's why we need this. Just remember this statement in your mind, okay? But the definition of unit step signal is this: t greater than 0 it is 1, t less than 0 it is 0, and at t equal to 0 it is 1 by 2. This you have to remember while doing any question and anything, okay? So this is the definition of unit step signal. Now second signal is Dirac delta or impulse function. It is represented by delta of t. It is infinity when t is equal to 0. It is 0 when t is not equal to 0. Now we will draw this. At t equal to 0, it is shown by an arrow mark, and the magnitude of this arrow is infinity as stated by the definition. Now remember this: for impulse function, its integration from minus infinity to infinity, delta of t dt is equal to 1 always. Remember this. So now what is unit impulse function? See, we don't use Dirac delta impulse function in engineering examples because its value is infinity at t equal to 0. So what we do? We use unit impulse function. So what is unit impulse function? Delta of t is equal to 1 when t is equal to 0. It is equal to 0 when t is not equal to 0. This is the definition of unit impulse function. It is drawn like this: at t equal to 0 it is shown by an arrow whose magnitude is 1. Now let's see third signal, unit ramp signal. It is represented by r of t. R of t is equal to t when t is greater than or equal to 0. It is 0 when t is less than 0. See, this is the definition of unit ramp signal. But what you have to remember is that the coefficient of t is here 1. So what is the slope? 1 divided by 1. Now I will clarify this statement. See, what is slope? Slope is change in y-axis divided by change in x-axis. So by seeing the definition of unit ramp signal, the change in y-axis is 1 divided by change in x-axis. Change in x-axis is also 1. Now I hope you get this. Now let me draw this. So before drawing ramp signal, you have to mark the plane like this. For better understanding, do like this, and when you have enough practice, then it will be easy for you to draw any ramp signal. Okay, so see this carefully. Now how you have to draw is, see, the change in y-axis is 1, so, and change in x-axis is 1. So how I will draw? I will draw like this, and then I will extend it like this. So change in y-axis is shown by this, change in x-axis is this. So slope is equal to change in y-axis, which is 2, divided by change in x-axis, which is also 2. So what we get? Slope 1. Now remember the statement. In ramp signal, r of alpha t is equal to alpha times r of t. Now I will take an example to explain this statement. Example is r of 2t is equal to 2 into r of t by this statement. Okay. Now let us define this function. It is 2 into r of t. So what I will get? 2 into t when t greater than or equal to 0, 0 when t is less than 0. So now see, what is the coefficient of t? Change in y-axis is 2 divided by change in x-axis, that is 1. So I draw it like this: change in y-axis is 2 and change in x-axis is 1, and then I continue the line like this. So I got r of t as well as r of 2t. So that is how unit ramp signal works, and you have to draw it like this. I hope you get this all. Thank you. Practice this, okay?